Gabe, you took a nice picture.
Why is mine funny?
So this is recording all your conversations. So if you want to start, cool. If not, go ahead. Yeah, all of it. So it's starting with a frequency table, and it's talking about the roulette wheel to the right. And it said over the past 50 spins, red has come up 17 times, black has come up 27, and green came up 6 times. First thing you got to know is what empirical probability actually means. Empirical probability is what actually happens. It's one of the first things we talked about in chapter 14, which would have been in December in this class. So empirical probability is what actually happened. So out of the last 50 spins, what's the empirical probability that it landed in a black space? 27 out of 50. Cool. Now, theoretical probability is if all things were equal. So in this case, how many black spots? Well, actually, how many total spots on the roulette wheel are there? Well, maybe it's a lot. What's the largest number you see?
29.
There's higher than 29. It's in the 30s.
37.
There's 36, but then there's 0 and 00.
38.
38 total. So what's the theoretical probability of the marble landing in a black space? You can count the number of black spaces, or you know that there's an equal number of red and black. There's 38 total. Take away the 2 green, you have 36. And then half of those are black, half of those are red. So we're looking at 18. Muy bien. Number 3, still at the roulette table, the marble has landed in a black region 10 times in a row. Is red due? Should you bet on black because it's in the middle of a streak? Or what is the probability of the marble landing in a black region again? What would you guys do?
It doesn't matter. You really don't.
Well, it doesn't matter. So what should be the probability of black coming up again? It's not 50-50. It is the same because all of these rolls would be independent. That's right. So since each of them are independent, since each roll the probability of being in a black space is going to be 18 out of total 38 every time. And it doesn't matter if there's 10, if black came up 10 times before it, or if you're due for a red. It doesn't matter. They're all independent. It's the same. Let me get a thumbs up on those first 3. Like, thumbs up, I think I get those right on a test. Thumbs down, I don't. All right, I do see some thumbs down. Let's go for doing more of those in a little bit. So number 4. So 78% of teachers at Trail have at least a master's degree or higher. First of all, true or false? True, actually. Yeah, for real. So just reading through those. Number 4, no reason anybody should be... Thank you. You're good. Oh, my bad. Nobody should be missing these because this is chapter 17. We just finished it. What's the expected number of teachers with a master's degree or higher you would expect to find in a group of 10? Close. Close. How do you find it? Yeah, just multiply. That's just n times p, where n was 10. Probability of success is 78. So 7.8, or like you said, 7 or 8. Probably a few more 8s than 7s. Standard deviation. This is what we were given yesterday. Do you have one? Wasn't here? Okay. Oh, they're over here? Where are they? Oh, you're good? All right. See ya. Bye-bye.
Probably the back.
Okay. Standard deviation. We have a formula. What is it? It's what? You got it. Good job. So N is still 10. P is 0.78. What's Q? 2. Multiply it out. Did you get something like 1.3? 1.31. So far, actually, I should probably ask D before C. What's the probability model that we're now using? There's 3 probability models. Which one are we going to use? One starts with a G. One starts with a B. One starts with a N.
Normal.
This one is not normal. This is not geometric. This is binomial. So let's talk about that for a second. There's a key word that there's no keyword saying geometric. Something I would say here is that we see in a group of 10, that's a fixed number of trials that clearly tell us binomial. So I'm going to say binomial. It says at least 6. Does that mean PDF or CDF? At least is not PDF. CDF. The C stands for cumulative. So CDF, that means how many trials? 10. Probability of success? 0.78. Low bound? All the way up to, you got it. This one, 95. About 95%. So we already answered this is binomial. So I'm going to say E now. What is the expected number of teachers you have to sample before you'll find one without a master's degree? Keyword here, what's the probability distribution we're going to use? This is, the keyword is first, what's the distribution? The probability model? Geometric, right. And what's the expected number or the mean for a geometric? 1 divided by P, right. Now, in this case, it says what's the expected number? You have to sample before you find one without. So what's the probability of finding one without? Say it? Yeah. So 1 divided by 0.22. And get about 4.54. So we'll either have to sample 4 or 5 teachers before we find one without a master's degree or higher. So last one, G. In a sample of 12 teachers, can you approximate the binomial model with the normal model? What do we need in order to use? Yes, say it again. Right, so if NP, N times P has to be greater than or equal to 10, so does N times Q. In this case, we already did NP. What was NP? NP was 7.8. Does that mean we're allowed to use the normal model? No. Ten successes and 10 failures, which we don't have. During this video, I'm going to still try and finish 6. We'll see if I run out of time. Seniors miss an average of 10.8 days a semester. I should have said days. 10.8 days a semester with a standard deviation of 3 days. Juniors miss an average of 5.4 days. Oh, there's only 30 seconds left in here. I'll pick this up on the next video.